In our previous lesson, we learned how our scanner scanned numbers, white spaces, identifiers, and keywords. So in this tutorial, we'll learn how the scanner scans symbols using the Char token function. So just between the scanner and the generate token function, we'll initialize the Char token function. This function is used to check for symbols. We also use two global variables here called parent count and brace count to check for invalid brace and parentheses in this function using the check field function declared here. So within the Char token function, we first check to make sure we are not at the end of file. Then using a switch, it matches the current token with our standard language symbol. If a match is found, it calls the make token to generate the token. Now, when we match an opening brace on line 184, we call the check field function with argument of 0 and incremented the parent count. When we match a closing parenthesis on line 189, we call the check field function again with argument of 1 and also decrement parent count. When we match an opening brace on line 194, we call the check field function with argument of 2 and increment the parent count. When we match a closing brace at line 198, we call the check field function with argument of 3 and decrement parent count. So these steps is taken to ensure that our braces and parentheses are declared properly. The check field function uses these two global variables, parent count and brace count, to store the number of open parentheses and braces respectively. If we match an opening brace in our Char token function, we increment the brace count, and if we match a closing brace, we decrement the brace count. Therefore, the brace count keeps track of how many braces are currently opened. Also, if we match an opening parenthesis, we increment the parent count, and if we match a closing parenthesis, we decrement the parent count. Therefore, the parent count also keeps track of how many parentheses are currently opened. So, if parent count or brace count is equal to 1, it means an opening parenthesis or one opening brace is yet to be closed. And if there is 0, it means that no parenthesis or braces is open. Right above the Char token, we declare the check field function. Now, the rules of declaring parentheses and braces in C++ states that for case 1, that is when the current token is a closing parenthesis, you cannot have a closing parenthesis when all open parentheses have been closed. That is when parent count is equal to 0. Therefore, if you include another closing parenthesis, it means you didn't actually close any parenthesis. Now, case 2 states that, which is when the current token is an open brace, you cannot have an opening brace when all opened parentheses have not been closed. So you cannot declare a brace within an open parenthesis. All parentheses must be closed before you can declare a brace, whether opening brace or a closing brace. Now, case 3, that is when the current token is a closing brace. It states that you cannot have a closing brace when all open braces have already been closed. Also, you cannot declare a closing brace when all open parentheses have not been closed. So this is how the check field function makes sure that the parentheses and braces are declared properly. We implement more error check in later tutorials. So back to our Char token function. In the Char token function, once a token is matched, we call the make token function to generate the token using the token type as argument to the make token function. There are also cases of tokens that consist of multiple characters. Example, double semicolon, which represents infinite loop, or here we refer to it as token infinite. Double hyphen, that is double minus sign, which represent the decrement operator or token subself. Double plus sign, which represent the increment operator or token add self. Then minus and equal sign, double and sign, double the or sign, the plus and the equal sign. So all these are instances of tokens that consist of multiple characters, that is double characters. So in such a case, if we detect any of the first character, example, if we match plus, we do not call make token to generate token plus. We first of all check the next token. If it is also a plus, then it's definitely an increment operator. Then we call make token to generate token as self. Else we call the make token to generate token plus. Also, in the case of double symbol tokens, we also increment token by 1 to point to the last symbol. So in our next tutorial, we'll discuss the lexical analyzer, function, make token, and generate token.